A comment about this though, right? It's fair enough to just apply them. How do we make this a bit trickier? What they'll tend to do is they'll test your understanding of the situation. Now before, remember how when we looked at integrals and when we looked at this trapezoidal rule, I said we're literally creating trapeziums here, right? So if I have, for example, this situation, we want to think about not only, okay, this is an estimation, I get it, it's not completely accurate, right? But when I'm drawing this trapezium out, I want to think about, is it an overestimation or an underestimation? And what I mean by that is think about how you construct your trapezium here, right? If I've got this situation, is this going to over or underestimate the area? So if I look at using the trapezium to estimate this over here, right? Do you think the actual area will be bigger or smaller than what this
bigger.
The actual area for this guy here?
Yeah.
So this trapezium here, can you see how it's getting more area, right, than the actual area under the curve? Because there's this little sliver on top, right? And that's because of the shape of the curve, right? If the curve is concave up, it actually turns out to be an overestimation. And on the opposite end of things, right, if I have something that's concave down, the same idea applies. If I'm looking at the area here, can you see how I'm actually missing out on this little sliver that's at the top there? And again, due to the nature of the curve, right? So if it's concave down, then I have an underestimation. So what they'll tend to do is they'll start like applying this to real world situations. Here we've got like a tent or something supposedly. And they want you to use the trapezoidal rule to approximate the area of the front of the tent. But then also they ask you, is it an over or underestimation? And you usually have to give a reason for that, right?
So can we just do it with like two trapeziums, one on each side?
Exactly right, yeah. So you've got your two kind of situations here, right? You've got, I'll rub this up. We've got here, so what are your true trapeziums? I'm still going to draw the table because we're kind of used to that layout, right? So f of x and x here. So what are your x values in this case? Well, we can call this as your 0 starting point, right? Let's call that 0, right? So I'm starting at 0. Now what are your function values going to be? Well, you start at 0, then when I get to here, right, that length, I'm going across 1.2 units, right? So I get to 1.2, but then what would I go one more, I'm going 1.2 across again, that would be 2.4. What are my function values this time though? Like what are your heights looking like at these various points? Because we don't have anything to substitute in, right? Sorry?
1.5, 1.8, 1.5.
Yeah, so think about the function values as the heights of your, I shouldn't say heights because that's kind of confusing, right? As these lengths here for your trapezium, right? So it's 1.5, 1.8, and then 1.5 again. So from there, then we can just use our trapezoidal rule to work it out, right? So we've got the area is approximately equal to your h value. So what's your h value in this situation? 1.2. So we've got 1.2 all divided by 2 outside of this. We're using the function values here, right? So 1.5. We still have 2 times, there's only one value in the middle here, but we still do 2 times that one. So 2 times 1.8 plus 1.5 again. You can evaluate that out for me. Yeah?
Wait, so can't you, on the second question...
Mm-hmm. This one here?
No, the partial down.
Yeah.
I already just guessed that it's going to be an overestimation.
Why is it an overestimation?
Because of the way it's shaped.
Exactly right, yeah. So what the actual question said, it also said justify, right? So the question said, all right, well, is this an over and underestimation? You also need to justify it. As Lawan said, yeah, can't you just look at the shape and know? You're exactly right? If you look at this, you're like, hey, have you tried the trapezoidal rule here? It's not capturing, it's capturing this stuff above the curve, right? So it's going to be an overestimation of the actual area because, yeah, exactly right, because it is concave up. Well done, Lauren. Okay. One more question. So here's a classic one, right? What they often do is that give you applied situations. I said this is like the application topic. So I'm going to give you the scenario here. The scenario looks something like this. You've got a vertical rock cutting of 0 to 300 meters, okay? And they're gonna give you all these like various heights here. So that's like 5. You guys like rock climbing, don't you?
Yeah.
So,
He does, look at calm.
and then that one there's 3, all right?
Like group strength.
And then we'll take, yeah. All right, so they'll give you a question like this, and they'll be like, hey, can you approximate the area using trapezoidal rule?
How big is it for the roof?
It's very big. Bigger than the Sydney CBD, I believe, Uluru.
It's huge.
Yeah, from what I've looked up.
Yeah, I was saying, I always thought it would be like around 300 meters.
Yeah, 300 meters long, right? So you notice how they haven't told you the number of subintervals? Generally, if it's a question like this, they will specify, or they'll just kind of like, it's sort of implied from this, right? So what's the situation you've got? You've got 1, 2, 3, 4, 5, 6 shapes here to use, right? And again, you can draw up the table because I think we're comfortable working with that, right? So can you see how they split these up, right? They're telling you from 0 to 100, 200, 300. But what should each of these values here be? These heights that I'm working, or the widths, if you want to think about it like that.
Like it's going up.
Yeah, because these should all be equal. So if you fill these gaps in here, right, these should all be the equal values, right?
Can you do it any other way other than, I mean, obviously you can, but
Yeah.
is the other way to do it other than the table?
Like the table is just a way of laying it out. It's not really like a correct way of doing it or anything. It's just how I structure it out. Some people prefer to write it differently, but this is the way I think kind of makes the most sense. So you can get all the information you need, right? Because what the good thing of the table is, okay, once I have these, I can fill in the heights really easily, right? So what are the heights like for this one?
10, 30, oh,
Okay, careful where you start from, right?
yeah. Oh, 5?
Yeah.
10, 13, 14, 11, 7, 6.
Right. So just be careful. Sometimes they like have stuff which is like this, and so the height there, if there's nothing that's there, it would just be 0, for example, right? So that's just something to be aware of.
Doesn't look like 13, I swear. It
Sorry.
does look like 13.
Now I just drew it very badly. Okay, cool. And then all you have to do is, okay, well, what's your height in this situation? Well, that's why I write at the table, because you have that information here too, right? The height, if you want to use the formula, was 300 minus 0 divided by how many trapeziums you have. We had 6, so that should be 50. And so then I can just straight up put it in. The area is approximately equal to h on 2, so 50 on 2. Outside of, now I'm only using these ones once. These ones in the middle I'm going to use twice there, right? So 5 plus 2 times all of these guys here. Let's see what we get. Let me put that in.
The bad thing about having classes you can't put things and things in a few times a week.
Yeah, so he shuts up quicker.
2,950.
2,950, and we should probably have had units for that other one as well, but let's work with square meters. Yeah. Well done, guys.